So in a previous video, we have seen how if you know of some amount that you have in the present, and if you know what the interest rate R is, and if you know how many years you want to go into the future, then you can determine the future value of that amount that you have in the present. So you can determine that. We have also seen that if you want to go in the opposite direction, so in other words, if you know what it is that you're getting at some point in the future, and if you know what the interest rate R is, and if you know what T is, then you can again figure out the present value. Well, it turns out there are more uses for this equation as well. Specifically, notice that this equation really is composed of four variables, right? So it's future value, present value, R, and T. Whenever three of these variables are known, you can rearrange it in some way to figure out the fourth one. And so this can be useful sometimes because sometimes you may know the future value, right? So what it is that you have, that you're looking for in the future, or what it is that you're getting in the future. You may know what amount you have in the present, and maybe you're interested in either finding out the interest rate when T is known, or you're interested in finding out time period T when R is known. This would be best illustrated using an example. So let's suppose that you were told that banks are paying an annual interest rate of 5%. If somebody asks you how long would it take for you to double your investment, then essentially let's make up some number. Let's suppose that in the present you have, say, $1,000. What would be the double of that? Well, the double of that would be $2,000. And so what you're saying is that if I had some amount like $1,000 today, like this would be your investment today, I'm basically looking to make it 2,000 at some point in the future. The question is that if the interest rate R is known, then how do I figure out how long it's going to take? So in this question, the present value is known, which is 1,000. The future value is known, which is 2,000. You know what the interest rate R is, which is being paid by the banks, and what you're really interested in is how long it's going to take for you to double your investment. I arbitrarily chose 1,000 and 2,000. You could have chosen 100 and 200, 5 or 10, 50 or 100. As long as future value is twice that of present value, that's really all that matters. And so if we plug these numbers into our equation, we're saying that a future value of 2,000 is basically 1,000, which is our present value, into 1 plus R, 1.05 raised to the power T. And so if you rearrange this equation, this is 1.05 raised to the power T equals to, so 1,000 will get divided over here, and so you'll just be left with 2. Now this equation, it turns out in order to solve this, you need a little bit of math, because you would need to take what are referred to as natural logarithms on both sides. And so you'd say natural logarithm here, right? So natural logarithm here, natural logarithm here, and natural logarithm here. The usefulness of that is then this T disappears from here and comes out over here. That's a natural logarithm property. So basically, this equation can be rewritten as T into natural logarithm of 1.05, which is equal to the natural logarithm of 2. And so T here then is natural logarithm of 2 over natural logarithm of 1.05, which if you do the math, will give you about 14.2067. So in other words, it would take you about a little over 14 years in order to double your investment if the banks are paying an interest rate of 5%. So one way to confirm that is that if you had $1,000 today, and if I asked you what would be the future value of this $1,000, about 14.2067 years from now, you would say future value would be $1,000 into 1.05 raised to the power 14.2067, which if you do the math, it will show you that this will be about $2,000 exactly. And so this is how you can use this equation to figure out the number of time periods it requires for your present value to become some known amount into the future.